feel like at some point all little kids want to be a marine biologist. They want to go study dolphins and whales or sea turtles. And I guess I just never really grew out of that. My name is Alexis Longmire. I'm a PhD student in ecology at UNC's Institute of Marine Sciences. I've got two projects going on right now looking at the landscape impacts of large-scale living shorelines. They protect a shoreline from erosion, but also rebuild lost habitat. The ones that I study specifically, they're these sill-like structures that hopefully should accrue oysters over time, build back a natural reef, and then oftentimes we plant marsh grass behind it. The first project is looking at whether living shorelines potentially negatively impact nearby seagrass beds. Here in North Carolina, we have like the highest acreage of seagrass along the East Coast, but we're losing it at a very high rate. In some areas higher than the global seagrass loss rate. And so for that project, I just go out and I just survey seagrass around living shorelines and see if over time they're moving away from the living shoreline, coming back, or losing density and things like that. My other project is looking at whether these large-scale living shorelines affect larger animal movement. And so I'm focusing in on predatory fishes, red drum, speckled sea trout, southern flounders, stingrays, and majority of those are really, really critical to our commercial and recreational fisheries here in North Carolina. So typically what we will do is we'll go out on the water, we'll take the boat over to one of our sites, and we will set up this really, really long 400-foot net off the side of the boat to enclose an area of a living shoreline. And within that, we can release a few tagged predators at a time with an array of receivers, and to let them interact with that living shoreline over the course of a few tides and see if they're able to get back there or not. In my experience, the stingrays don't seem to have any problem going behind the living shoreline, but they're also really flat, so they're probably one of the few species that can swim over the top of the living shorelines. So if you're a really big red drum, for example, you're not getting over the top. In North Carolina, the permitting requires that for every 100 feet of structure, there's a 10-foot gap. So that's the point, is to entrap animals in the area and see whether they can utilize those gaps across the tide to forage and get food. There is absolutely no way I could do all this by myself, or even with just one other person. I rely very heavily on my lab mates, my friends, colleagues here at the Institute of Marine Sciences, but that's just sort of the community that IMS is. It's very collaborative, and I think that really enriches the sort of research that we can do here and accomplish here.